discuss about Taylor series. So first we discuss about convergence of a series, then we discuss about how we prove the Taylor series. So first we define the convergence of a series, then we formally write the statement of a Taylor theorem, then we prove the Taylor theorem. So what is the convergence of a series? So first of all, convergence of a series, we write here convergence of a series, convergence of series. So let Z1 plus Z2 plus Z3 up to infinite number of a term be a series of complex number. So you may also write this one in a notational form. This one is the what? Summation n equal 1 to infinite Zn. So this series converges to S. This series converges to S if the partial sum of this series, what is the partial sums? Means that here we write what? Summation. This one is the Sn partial sum, not a n, this will be capital N. Sn equal n equal 1 to capital N Zn. So what is the meaning of this one? S1 is a how many number of a term in a partial sum? One term. N equal 1. N equal 2, Z1 plus Z2. N equal 3, Z1 plus Z2 plus Z3. So if the partial sum, the series converges to S if the partial sum of a sequence this partial sum of a sequence converges to S. So what we say that, then we directly write what? This series summation n equal 1 to infinite Zn converges to what? Converges to S. So this one is our definition of a series. So here, one remarks, if we noted down the remarks, means that this series converges to S if nth term of this series tends to 0 as n tends to what? N tends to infinite. So series converges if nth term of a series tends to 0 as n tends to what? N tends to infinite. What is the meaning of this one? Means Zn tends to what? Tends to 0 as n tends to what? N tends to infinite. Then series converges to the what? Converges to the S. Now one another remarks, here we noted down, the limit of a sequence is a what? Unique, at most one limit. So sequence have at most one limit. At most one limit. So what we can conclude that, so series have at most one sum. So this one is a what? This one is another remark. So this one is remark number 1. This one is remark 2. Now we try to define the power series. So what is the power series? So here we also noted down this one is a what? Remark 3. So power series for a function fz, if they express this one, summation n equals 0 to infinite an z minus z0 to power n, then this function is called have a power series, can be expressed in a power series where z0 is a what? Z0 is a center for the series, and an is a constant. Constants. So with these three remarks and definition of a convergence of a series, now we are going to write a formal statement of a Taylor theorem and proof of a Taylor theorem. So now first we write the statement of a Taylor theorem. So what is the Taylor theorem? Taylor's theorem. What is the statement? The statement of a Taylor theorem is if fz is analytic inside the circular disk, what is the circular disk? Circular disk is a mod of a z minus z0 is a less than r. But z0 is a what? Center. R is a what? R is a radius. Then for all z in circular disk, all z in a circular disk, there exists a power series. There exists a power series such that, what is the power series? Power series is fz equal summation n equals 0 to infinite an z minus z0 power n. So this one is a what? This one is a Taylor's theorem. What is the value for an? An is an equal nth derivative at z0 divided by factorial n. This one is a what? This one is a statement of a Taylor theorem. Now we are going to prove this theorem. Means if fz is analytic inside the circular disk, this z minus z0 is less than r, then for all z in a circular disk there exists a power series such that fz equal n equals 0 to infinite an z minus z0 n, where an is a nth derivative of fz at z equals z0 divided by factorial n. Now we formally prove this one. Now what is the proof? Means the proof of this one. Proof of this theorem. So how we prove this theorem? Means what is the given? Given is the fz is analytic inside a circular disk, this one. So this one is a circular disk. Suppose this one is a circular disc. This one is a circular disc. This one is a circular disc. Center at Z0. Center at Z0. Z0 is the center. What is the radius? The radius is a capital R. Capital R. So Fz is analytic inside this circular disc. Inside this circular disc. Then this series is valid for all Z inside this one. Suppose here we take a set, arbitrary we take a set inside this circular disc. Inside this circular disc. Now we draw another circle centered at Z0. Centered at Z0 which enclose the point Z. Which enclose the point Z. We draw a circle which enclose the point Z. And suppose this radius of this circle is a R. Small r. Small r. Z0 at the center and Z inside this circular disc. So here, suppose this one is a what? This one is a C and this circle is a what? This one C1. C1. Now, here we are going to write 1 upon W minus Z. W minus Z. What is the 1 upon W minus Z? W is a what? W is a point on a circle C1. W is a point on a circle C1. Then, now we try to write W minus Z term of a Z0. So, how we write this one? 1 upon W minus Z0 plus Z0 and minus Z. So, if we take W minus Z0 outside and then this become what? Then this become 1 upon W minus Z0 outside. Inside, what will happen? 1 minus Z minus Z0 divided by W minus Z0. This one. This one. Now here, if you closely observe, Z minus Z0, distance, positive distance from Z minus Z0 is always less than the distance from W minus Z0. What we say here means mod of Z minus Z0 divided by W minus Z0 is a what? Less than 1. Why? Because mod of a W minus Z0, mod of a W minus Z0, difference of this one. Difference of this one is always greater than difference of a Z minus Z0. Why? Because Z lie inside this circle or inside this circular disc. Then W lie on in a circular disc and Z lie inside the circular disc. Then obviously the difference from the center is a less than 1 because denominator is a greater than numerator. So here Z minus Z0 divided by W minus Z0 is a less than 1. Now, here we are going to use one very important expression in this form. Means here we write in this form. First we write this form. What is the form? Means we know that what is the value of 1 upon 1 minus Z? If a mod of a Z is less than 1, then this one is a what? 1 plus Z square plus Z cube up to how many number of terms? Infinite number of terms. Where mod Z is a what? Mod Z is a less than 1. Mod Z is a less than 1. Now, if we write a partial sum, what is the partial sum? Partial sum means Sn capital N. This one equals summation n equals 0 to n minus 1. 0 to n minus 1 Zn. Z to power n. So if we write this one, this become what? This become 1 plus z square up to what? Z to power capital N minus 1. So what is the value for this one? The value for this one is just sum of a series having how many number of term? There is an n term. So 1 minus a is a 1. 1 minus z to power n means how many number of term here? N term. Z divided by 1 minus r. What is the value? 1 minus z. So if we simplify this one, this may be written as 1 upon 1 minus z minus z to power n divided by 1 minus z equal what? Summation n equals 0 to capital N minus 1 z. Now if 1 minus z on a right hand side and all the terms keeps in a left hand side, then what is the value? 1 upon 1 minus z. 1 upon 1 minus z, this term equal summation of n equals 0 to capital N minus 1 plus z to power n plus z capital N divided by 1 minus z. Here z is a what? Mod z is a less than 1. Here mod z is a less than 1. Mod z is a less than 1. So here also this one is a less than 1. So in place of a z, if we write what? Z minus z0 divided by w minus z0, then we can write this one, means this expression like this one, 1 upon, if we write here 1 upon w minus z equal 1 upon w minus z equal 1 upon w minus z0, w minus z0, this one is a term, then 1 upon 1 minus z, here we assume that this one is a 1 upon 1 minus z, 1 upon 1 minus z, 1 minus z. So in place of a z, what we write? Z minus z0 divided by w minus z0. So in this manner, here this becomes summation n equal 0 to n minus 1 into z to power n. Z to power n is z minus z0 divided by w minus z0 to power n plus what? Plus, if we erase out this one, then it's become easy to write. If we write in this way, we erase out this one, and try to write here, not here. If we write this one, 1 upon w minus z equal 1 upon w minus z0, and what is the value here? Inside summation n equal 0 to n minus 1, Zn, here this one is a Zn, so z minus z0 divided by w minus z0 to power n plus z minus z0 divided by w minus z0 to power capital N. This one is a series here, this series here. So divided by 1 minus z minus z0 divided by w minus z0, this one. So here we write it this way. So simply we write what? In place of a z, because mod of a z is less than 1, we write in place of a z minus z0 upon w minus z0. Then this become n equals 0 to n minus 1 in place of a z minus z0 divided by w minus z0 to power n plus this term is free from the summation, so z to power n divided by 1 minus z. So this one is a. Now we also erase out this one. Now we try to prove this one. Okay. Now if we closely observe this one, if we simplify this expression, then 1 upon w minus z equal, this one become what? This one become summation, first term becomes summation n equals 0 to capital N minus 1 z minus z0 to power n divided by w minus z0 to power n plus 1, because w minus z0, this one multiplied by here, w minus z0 to power n, this become n plus 1 plus what will happen here? Z minus z0, z minus z0, z minus z0, z0 to power capital N divided by w minus z0, we write whole term to power capital N. If we simplify this one, then what will happen? This will come into w minus z0 divided by what? Divided by w minus z0, then this become w minus z0 plus z minus z0, then this become w minus z. W minus z. So this one is the expression. Now multiply by f of w and integrate with c1. Integrate with c1. C1 is a what? C1 is a circle which includes the point Z and W lie on a boundary of a C1. Now, if we integrate this one, then integrate closed curve C, this become f of W divided by W minus Z dW. This one is the first term. It's a left hand side. What is the right hand side? Right hand side, what is the first term? First term becomes Z minus Z0 to power 0 become 1. W minus Z0 n equals 0, then this become 1. So here we write what? First term, if we expand this one, for sake of simplicity, if we expand this one, I write the first term, then what is the value? Value become integrate over C1 f of w for n equals 0, this become 1 and this become w minus z0 and dw. This one is the first term. Now what is the second term? Similarly, second term become z minus z0. Z minus z0 is free from the what? Free from the integration, because here we integrate with respect to w. So here we write the second term z minus z0 n equal 1, then this one is a 1. Integrate over c1 f of w divided by w minus z0 whole square dw. Similarly, if we write a third term, this one is a z minus z0 square integrate over c1 f of w divided by minus z0 q dw, and similarly we write n minus 1 number of terms. And this one is the last term. What is the last term? This become this become what? This become z minus z0, z minus z0, z minus z0 divided by what? W minus z0, W minus z0, W minus z0 to power what? To power n, capital N, into W minus z0 divided by W minus z. And here we write in term of integration. If we write in term of integration, what is the value here? If we write in term of integration here, I am not multiplying the f of w. So this one become integrate over C1 f of w z minus z0 to power n, capital N, into f of w divided by w minus z dz into w minus z0 to power what? N minus 1. So here we denote this one is a remainder term, means this one is a Rn. Here we denote this one is by the Rn. Now, if we closely observe this expression, then what will happen? Here, if we try to write here, if we delete out this one and try to write here, now, by the Cauchy integral formula, what is the value for this one? The value for this one become what? The value for this one become fz, because f of w minus z is inside a point in a closed curve C1. Z is a point inside a closed curve C1. Then here we able to apply what? Cauchy integral formula. If we able to apply Cauchy integral formula, because fz is a what? Fz is analytic inside a closed curve C. Then fz is also analytic inside this one, and z is inside the closed curve C, where the function is analytic. Then be able to apply what? Then be able to apply a Cauchy integral formula. Then by the Cauchy integral formula, what is the value for this one? The value for this one become f of z. Now, if we closely observe first term of a right hand side, z0 is also lie inside a closed curve C1. Then here also we able to apply what? Here we also able to apply a Cauchy integral formula. According to the Cauchy integral formula, what is the value for this one? 2 pi I f of z0. So here similarly next term is z minus z0 2 pi I f dash z0. Similarly next term is z minus z0 whole square 2 pi I f double dash z0 divided by factorial 2. Similarly, there is a remainder, means the last term, Rn. Now, if n tends to infinite, then what will happen? N tends to infinite, means if there is an infinite number of terms, then if we closely observe this z minus z0 upon w minus z0, the remainder term Rn, this one is a Rn, here we denote this one is a Rn. Z minus z0 upon w minus z0 is a less than 1. If less than 1 and capital N, here this one is not a small n, capital N tends to what? Capital N tends to infinite. If capital N tends to infinite, then this term tends to 0, because the ratios of these two terms is less than 1. If the ratios of these two terms is less than 1, is the power of a capital N. If capital N tends to infinite, then this term becomes 0, tends to 0, then whole term tends to 0. If capital N, and here how many number of term? N minus 1 term, then this one is a nth term, capital nth term. So if capital N tends to 0, then what we say that Rn tends to what? Rn tends to 0. Means remainder term tends to 0. Why? Because this one is a power of a z minus z0 divided by w minus z0, and this one is a less than 1. If this one is a less than 1 and capital N tends to infinite, then this one tends to what? Infinite. Closely observing, and we try to formally prove this one. You may also say this one is a less than 1 and this one tends to infinite, then we say that this one is a 0. You may also write this one in this way, means f of w upon w minus z. F of w upon w minus z is analytic everywhere, so f of w upon w minus z is a continuous in this region, and so what will happen? This one is a bounded. So we write what? F of w upon w minus z. W minus z is a what? Less than m. M is a what? M is a any positive number. So taking the mode of both sides, Rn, this one converted into a m, and w minus z0 is a what? W is a what? W is a here. W is a here on a C1. So W is on a C1, so W minus Z0 is a what? W minus Z0 is a radius. So this becomes this one less or equal to in term of a m. This one is a m, and this one is a r to power n, and this one is a z minus Z0 is a free from W. So this may be written as z minus Z0 to power mod of this one is a n into integrate over C1 dW. So what is this one? This one is nothing else. This one is a length of a C1. What is the length of a C1? This one is a circle, and what is the length of a C1? This curve is what? 2 pi r. So here W minus Z0 is small r, not a capital R, r to power n. So this one equal what? Less or equal m divided by r to power n, and here z minus Z0 to power capital N mod of this one, and this one become 2 pi r. R and r, this become r to power minus 1, cancel out, then z minus Z0 upon r is what? Less than 1, so this one becomes 0. So what is the value? Value tends to 0, as n tends to what? Capital N tends to what? Capital N tends to infinite, then R n tends to 0. This one is a formal proof of this. Now, if we closely observe, now this term become what? This term tends to 0. If capital N tends to infinite, how many number of terms here? N minus 1 terms. So if N tends to infinite, then this series tends to what? Infinite. And 2 pi I common from left hand side and right hand side. Then if we simplify this one, then this becomes f of z equal f of z0 plus z minus z0 f dash z0 plus z minus z0 whole square divided by factorial 2 f double dash z0, and so on. How many number of terms? Infinite number of terms. If we write the nth term, z minus z0 to power n, fn z0 divided by what? Factorial n, up to how many number of terms? Infinite number of terms. So this one is a what? This one is a proof. If we write like a power series, so we may also write this one in terms of a power series. If we erase out this one, then what is the power series? In terms of power series, what is the value? In terms of a power series, what will happen here? F of z equal what? Here we write this one is A0 plus f dash z0 is a what? A1, z minus A1, z minus z0, and this one is a what? A2, f double dash z0 divided by factorial 2, this one is a A2, A2 z minus z0 whole square. Similarly, an z minus z0 to How many number of terms? Infinite number of terms. So if we write this one in term of a notation, n equals 0 to infinite, fz equal what? Fz equal an z minus z0 to power n. Here 1, then power 1. Power 2, then here 2. What is the value of an? We closely observe a0 is the f of z0. a1 is the f dash z0 divided by factorial 1. a2 is the f double dash z0 divided by factorial 2. Similarly, what is the an? an is the fn0 fnz0 divided by factorial n. So this one is a what? This one is a proof of a Taylor series. Proof of a Taylor theorem. Proof. So this one is a proof of a Taylor theorem. So how we solve a numerical example? This one is a very easy, not a very tough task. Just fz is a given. If fz is a given and fz is analytic inside a circular domain, circular disk, z minus z0 is less than r, and z is any point inside a circular disk. So what is the meaning of this one? Means you may find the Taylor series expansion about a point where the function is a what? Function is analytic. So always we find the Taylor series expansion about a point where the function is a what? Function is analytic at that point. So z0 is inside this one, and at z0, because fz is analytic inside this domain. So at z0 function is a what? Function is analytic. So we find fz, f dash z, f double dash z, f triple dash z at z equal z0. Then putting here, then we find what? We find the value of a0, a1, a2, a3 up to an, and putting here, then we able to find out a solution. Then we able to find out the Taylor series expansion. One another way means we write in this form. We write in this form means a numerator upon denominator is less than 1. Then we expand this one as a power series, means 1 plus z square plus z cube up to z to power n. Then we also able to find out the Taylor series expansion. So before solving solving the numerical problem, there is one another concept, radius of a convergence. So what is the radius of a convergence? First we discuss about the radius of a convergence, then we solve a numerical example and find a Taylor series expansion as well as radius of a convergence. So what is the radius of a convergence of any series? So first we discuss about the radius of a convergence. So what is the radius of a convergence? So radius of a convergence, radius of convergence, radius of a convergence, radius of a convergence. Suppose there is a power series for any function fz equal summation n equals 0 to infinite an z minus z power n. Where is the center? Center at z equal z0. Center at z equal z0. Now, what is the radius of a convergence? So, there is one very important theorem and known as Abel test, also Abel theorems, What is the statement of Abel's theorem? I am not going to prove of Abel's theorem. Just use the concept of this one. Means if any series is converges at a point Z1, if this series means if not any series, if this power series converges, we write here clearly, if the power series is converges at a point Z1, then it must be converges at all point inside. So if the power series converges at a point Z1, then it must be converges at all point inside the disk. What is the disk? Disk center at Z0, and what is the radius? Radius is Z1 minus Z0. What is the meaning of this one? Meaning of this one is what? Meaning of this one is just suppose this one is a what? Z0. And if series converges at this point Z1, then it must be converges in all point of this disk. What is the center? Center at Z0, and what is the radius? Z1 minus Z0. And if a point Z2 where the series diverges, then it also diverges for all z such that mod of z minus z1 is greater than z2 minus z0. So z minus z0 is greater than z2 minus z0, sorry, because here z minus z0. So what is the meaning of this one? Graphically, we try to understand what is the meaning of this theorem, this Abel test. There exists a point Z2. Then there exists a disk like this one. There exists a disk, this one. Inside this disk, what will happen? Inside this disk, at all point this power series converges. Outside this region, the series diverges. This was the point Z2. Series diverges. Here, series diverges. And this one is the reason where series converges. And this one is the reason. This one is a reason of a doubt. This one is a what? This one is a reason of a doubt. A reason of doubt. Reason of a doubt. Means in this reason, series may be converged, may be diverge. But if Z1 is at any point where the series converges, then it must be there exists a disk. This disk inside this disk at all points series must be converges. If there exists a point Z2 where the series diverges, then above means beyond this disk, the series diverges. But in this reason, this common reason, you cannot say either series diverges or diverges. So this one is a reason of a doubt. Means here maybe the series converges, maybe the series diverges. So now, what is the value of R? What is the value of R? R is what? What is the value of R? So how we identify what is the value of R? So Z0 may be the what? Z0 means at one point this will converge, and that point is a what? That point is the origin. So what is the R? R must be greater than 0. If series is converged in the entire complex plane, then what is the R? R is infinite. So R varies from what? R varies from 0 to infinite. R varies from 0 to infinite. Means if we are able to find out a reason where the function is analytic, know any point where the function is not analytic, that region is called what? Region of a convergence. And the radius of that region is called what? Radius of convergence. So here, this one is a what? Geometrical interpretation of a radius of convergence. Mathematically, how we find? There is a derivation. This one is called what? This one is called Abel test. This one is called what? Abel's test. Abel's test. Abel's test. So the value of R is greater than 0 and less than infinite. So R can be calculated at what? There is a mathematical definition of a radius of a convergence. Means R is 1 upon R equal. This one is so this may be defined as limit n tends to infinite supremum of an to power 1 by n. This one is called basically root test. Root test of a what? Root test of a either series converge or diverge. And second one is called what? Second one is a ratio test. 1 upon R equal limit n tends to infinite an plus 1 divided by a R. If we are able to find out the value of a 1 upon R, then obviously we are able to find out the value of R. Reciprocal of this one become what? Reciprocal of this one become the value of a radius of a convergence. And this one is called what? This one is called ratio test. Ratio test. What is the value of an? An is this one. This one is an. An of a power series. An is a power series. Then be able to find out the an plus 1 and be able to find out the value of an. Once we find the value of an plus 1 and an, then 1 upon R is a limit n tends to infinite. The value of this limit represent the 1 upon R. Then R is a reciprocal of this limit is a what? Is a radius of a convergence. This one is a mathematical definition of a radius of a convergence. And radius of a convergence may be 0, may be infinite. Means radius of a convergence lie between 0 to infinite. Now we try to solve one numerical example, and means we try to find out Taylor series expansion of a function which is analytic inside a circular domain, circular disk.